Name's Pat Warner. I'm the additive manufacturing manager for Renault Sport Racing's Formula One team. I've been kicking around in Formula One for 32 years and additive for 22 years, so I've been around the block a few times. So why do we use additive in Formula One or motorsports, but in my case, specifically Formula One? Formula One is rather a unique business case, I guess. We are very low volume. We're a very high iterative organization, so we will manufacture components for a single event, use them once, throw them away, never use them again. Everything is extremely low volume. As with most people in additive, we started with polymers, small, low volume manufacture. A production run to us is 5. So additive manufacturing with no tooling, quick turnaround is absolutely ideal for our application. We literally, quite literally, take parts out of a machine on Thursday and put them on a car on Friday and run them. That's our sort of operating procedure. Everything is in Formula One is last minute because we are working from results we found from the previous race to change the car for the next one. So lead times are very short. We don't have time for tooling, and we're relatively happy to pay what most people would consider a silly amount of money if it's performance on the car. Collaboration, we like to collaborate as well, so we have relationships with machines manufacturers, material manufacturers, and other like-minded companies as we try and develop what we do. One set of parts on that slide is for a Formula One car, and the other is from a rather major aerospace company for an aircraft. And if you look at the next slide, you'll kind of see where one of them went. So it'll give you a clue as to which ones were ours. Customization is a big thing for us. So the item on the left is a shroud that fits on the wheel nut gun in the pit lane. To do a 2-second pit stop or a 3-second pit stop, a standard wheel nut gun doesn't have all of the gadgets and gizmos and comfort and feel that our mechanics require. So we modify them, add switch gear for the lollipop lights, for the traffic light system for the driver, and make the whole thing more ergonomic for the mechanic. So those get thrown around in the pit lane quite viciously, but we literally go through dozens of iterations of those every year as we improve our wheel nut guns and our design and our speed. The item on the on the right is an air duct, and it's been around the block a bit, this part. 3D Systems have used it for a number of years as a demonstration for DFAM. It was one of those ones I was very pleased to see the designer just got it. He understood. So that component is very light. The main wall thickness on that duct is 0.7 millimeters. He's added stiffening ribs where he needs it to hold it in place. It has a debris collector to stop any debris going down the duct and interfering with the electronic systems. And it has all the mounting interfaces to attach it to the car in 3 positions, as well as interface to the electronic systems at the other end of the bodywork. Very nice part, couldn't be made any other way. And as we turned up at different circuits with different ambient temperatures, we could adjust the shape of the duct to increase or decrease the amount of airflow, which meant, again, we were customizing per event, even on something like airflow. Design for additive and why it's important. Well, we're all about speed, but we're also very much a right first time industry. If it doesn't work straight out of the box, we rarely get the time to go back and do it again. We don't have years to develop our product. We have literally days, or in the case of a new car, months. So we'll start a new car in August and it'll be on the floor in January and ready to run in February. That's standard operating procedure in Formula One, and we all do the same. It's an immense task, but we really can only learn by our mistakes once the car hits the track. So it's important that we get it right, and that's been quite an interesting evolution within additive. Most of our design team are sort of jack of all trades, so they have to understand how to design for subtracting machining, for composite laminating, molding, and now work their way through additive. And it's been an interesting cycle in getting there. So the part on the screen is our roll hoop. It's static loaded, so a one-hit wonder. It's only ever loaded if the car turns upside down. But before we can fit it to a car, we have to prove it will take a 17-ton load test in 2 directions. So that's our load cases. And we also have to fit within the aerodynamic envelope. So the shape of the car is defined before we start designing everything that makes the car. To an extent, full-size design can feed back to aero that they need some changes made, but on the whole, once the aerodynamicist has set his shape, the car designer is pretty much stuck with it and has to figure out how to contain everything within that envelope. As a packaging exercise, that's quite horrendous. Formula One is an extremely stressful environment for anything. So we see massive changes in temperatures. We see huge G-forces throughout the course of a race. I think if you follow Formula One, you'll be aware of the normal G loadings that are spouted of sort of 6G on the brakes and 5G in acceleration and 4.5G around corners. What people don't very often realize is when a driver clips a curb and you see the inboard wheels leap over the curbs, the car is subjected to sort of 30 to 40 G and Z, albeit for a split second. But that is a split second repeatedly, pretty much every lap through a couple of corners. So quite an aggressive place. So we designed this roll hoop. So we had the constraint of the car shape to figure. We had the load case to figure. We also needed to reduce weight massively. Weight is obviously key in Formula One. We're all about performance and reducing weight. This item had been cast for a number of years using an additive pattern, but we decided we could go a step further by going additive metal. So having the design constraints of the car in mind, we also had to figure out the design for manufacture. That meant we had to make it fit within the envelope of the machine. We had to build it in an orientation where all of the internals galleries had no support structure, because we didn't want to have to get inside and do any finishing, any support removal. And if we couldn't remove the supports, we didn't want the increase of weight of the excess material. So the designer spent a lot of time looking at the right orientation to build this part, and then the designing it not only with the load cases in mind, but also making sure that all his webs and fillets and features on the inner surfaces were free from supports. That part was then inspected. Relatively good. It's not an aerodynamic part as such, so we had a little bit of leeway. The whole thing is shrouded with a carbon fiber shroud to give it its aerodynamic shape, but it has to fit within those skins. And then comes the big test. As I said, we're unable to fit this onto a car and put it on a track unless we've passed this test. It's quite an aggressive push. It's only a push test. It's not a hit, but it's loaded, as I say, it's 17 tons, one in that direction and one from the rear at a similar sort of angle. But quite an aggressive test out of the box. On track validation, we will additively manufacture lots of parts before we get to the point of manufacturing them in our normal method, mainly due to speed. We can put a part on the car in a couple of days. We can test it on a Friday. We can make sure it does what it's supposed to do. If we really like it, we'll continue to race it, and then we'll follow up with the production items, probably in carbon fiber or machined from solid later. End use components. Our exhaust is quite a complex beast and a big user of additive. In fact, a lot around the turbine area and engine is additive, but much of the exhaust is now. So that the part on the left there is what we call the debris catcher. So our exhaust is so large that the wheel in the turbine, the turbocharger, could eject straight out the rear of the car. So we have to have something in place that will stop it if it comes off the spindle. And obviously make sure it can't hit the guy that's following. The right-hand part is our tailpipe. That particular year's car had a single rear wing pylon coming from the rear crash structure or gearbox up through the middle of the exhaust to hold the rear wing in place. So it had a rather complicated shape with gas flow required through the middle of the pipe. Our aerodynamics team use an awful lot of additive, both polymer and metallic. So the small widgets on the left at the bottom there are wind tunnel based. But we also put in the region of 600 parts a week through the wind tunnel that are polymer manufactured, both SLA and SLS. So that keeps us rather busy. The vane top left there was a very lightweight aluminium component for the race car rather than the model. It's a 0.5 millimeter skin with a very lightweight lattice structure that was only really there to ensure the skins stayed where they were put, because it gets a little bit of push in the pit lane more than it does on the track. Lots of weird and wonderful shapes designed to fit within that packaging environment that I was talking about earlier. So that is just really, we needed 3 meters of pipe in a very small space. And to be able to do that, we couldn't make it any other way than additive. These were all done on a medical line so that the internal channels were perfectly clean. But basically that's just a big coil of 5 millimeter titanium pipe that we had a need in the front and rear of the car for our suspension. We don't always get it right, and when we don't, it's very public. But so we strive to get our design for additive correct, but it's you may see when it goes wrong. So observations. I'm running out of time. New technical regulations for 2022 will open up a range of materials for us that can only be used additively. The FIA are very aware that additive manufacturing is extremely sexy, and they like us to try and be at the forefront of innovation. Formula One operates an allowable materials list. It's an allowable materials list because that's much shorter than the banned materials list. These are all available in our technical regulations if you want to download them from the FIA website. If you're really struggling to sleep one night, then it's an interesting read. Otherwise, I'd leave it well alone. But these regulations are now being driven towards promoting additive manufacturing. So currently there are materials that we are not allowed to put on the car we're not currently allowed to put on the car at all, period, end of. Most of those are done with expense being the key driver. Is entering a new realm of cost capping. But as they started working towards that, they started taking away some of the more expensive exotic materials and saying you can't use these. To try and promote additive, some of those materials are coming back, but only if that component is additively manufactured. We are an industry that thrives on interpreting the rules and bending them in to meet our needs. That's pretty much the way Formula One teams operate in general. So we had to put into that regulation that the part had to be within a percentage. The final part had to be within a percentage of the near net shape of the part that was additively made, i.e., unlike what was presented earlier, Formula One teams would print a billet and then machine it later if they thought there was a technical advantage in doing so. It would be horrendously expensive. Nobody in additive would consider it to be a good idea, but Formula One engineers would probably try it. So we had to sort of write into those rules that unless the part was relatively close to the final shape, it would be disallowed. Where can we improve? Well, the mindset of the design team is moving them over from conventional to additive is a definite challenge. We're putting quite a lot of effort into training our design team, but we have a constant rollover of designers. It's quite normal for designers to move around within Formula One, or even move in, decide they don't like it, and move on again. So it's a constant sort of challenge to train those people to think in an additive way. Obviously, if something like this starting at the university level can be more proactive to the sort of designers that come our way, then that would aid us a lot. A lot of designers turn up thinking they know 3D printing because they did some at uni, but realistically, they played with a filament printer on a desktop rather than something actually usable in our world. Mechanical properties have been an also troublesome thing for us. Understanding fatigue is difficult. Whilst we have a relatively short lifespan of 2 hours compared to 25 years in aerospace, as I said, it is subjected to a rather brutal environment in that time frame. So getting that right and making sure we have the confidence of being right first time and we're not going to have one of those embarrassing failures is quite important to us. That's it. I'm done.